to Sri Sathya Loka Seva Gurukulam online classes. We've been learning differentiation. In today's video, we are going to learn second order derivatives. So let's first see what are second order derivatives before we get into solving the problems. So, let's suppose we are given a function y is equal to x squared. The derivative of this function, that is when we differentiate this function with respect to x, what do we get? Dy by dx is equal to 2x. So this is called as the first order derivative. When we differentiate it the first time, we get the function that's called as the first order derivative. Now, when we differentiate this particular function, the first order derivative, with respect to x again, that is d by dx of this, let me call this as y dash, then I get the second order derivative. When I differentiate this with respect to x again, I get 2. That is, this is called as y double dash or d square y by dx square. This is nothing but d by dx of dy by dx. So this is represented as d square y by dx square. Or you can call it y double dash, or if we name this as f of x, you all very well know that the first order derivative is expressed as f dash of x and the second order derivative can be expressed as f double dash of x. So can we move ahead solving the given problem? So this is our f of x given. So let's take it as f of x. This is the function that's given. X power 4 plus 3x cube plus 9x square plus 10x plus 1. We are asked to find the second order derivative. So first let's differentiate it with respect to x. So differentiating with respect to x, we get the first order derivative. So that is represented as f dash of x will be equal to, when we differentiate this, we know how to differentiate a polynomial, x power 4 using Newton's power rule. When differentiated, 4 comes down as the coefficient, x power 3, 1 less in the power, plus 3 is a numerical coefficient of this variable term, you will keep it as it is, into x cube on differentiation gives you 3x square, plus 9 is a numerical coefficient, keep it like that. X square on differentiation gives you 2x, plus 10x on differentiation gives you 10, and 1 is a constant term which on differentiation gives you a 0. So it gets nullified. I'm not writing it here again. So let's simplify and express this polynomial in a proper way. So we have 4x cube plus 9x square plus 18x plus 10 is going to be our first order derivative. Now I'm asked to find the second order derivative. In that case, I need to differentiate the first order derivative. So when I differentiate f dash of x, what do I get? Differentiating again with respect to x. So f dash of x gives me f double dash of x, the same function differentiated twice. This is 4x cube, so 4 into 3x square plus 9 into 2x. I'm sure by now you all know how to the basic rules of differentiation of a algebraic function. If in case you have any doubts, go back and watch the previous videos and then get back to this. Plus 18x on differentiation gives you 18, because always x on differentiation gives you 1. Plus 10 gets nullified because it's a constant term. So here you have 12x square plus 18x plus 18. That's going to be your f double dash of x, or your second order derivative. So this is your second order derivative. I hope you all understand. So let's move on, solve more problems. Now, to have a recap, let's see how to differentiate functions like this. This is not a trigonometric function, but this is just a recap of whatever we've learned so far. Now, we've been given that y is equal to 3 minus v by 2 plus v, and v is equal to 4x by 1 minus x square. How do we go about differentiating or finding dy by dx? So we know that according to the chain rule, dy by dx is equal to dy by dv into dv by dx. You get dy by dx. Whenever y is given in terms of a third variable, this is how you have to deal with it. So now we have y is equal to 3 minus v by 2 plus v. We are going to find dy by dx using the chain rule. Now y is equal to 3 minus v by 2 plus v. So how do we find dy by dv first? Dy by dv will be equal to 2 plus v the whole square. This is of the form of a fraction. A numerator has a function, denominator has another function. So we use the quotient rule, wherein we first keep the denominator unaltered, differentiating the numerator. 3 minus v on differentiation will give you minus 1. 3 on differentiation gives you 0. V gives you 1. Since it's minus v, it's minus 1. Minus. Now the numerator is kept unaltered and the denominator is differentiated. 2 plus v on differentiation will give you 1, because 2 is a constant term which gets nullified on differentiation, and v on differentiation gives you 1. So this is equal to minus 2 minus v minus 3 plus v, when we open the brackets up, and 2 plus v the whole square. So we have minus 5 by 2 plus v the whole square. This is our dy by dv. Now, let's find dv by dx. So dv by dx, again v is a fraction given in terms of x. So we'll use u by v. So keeping the denominator unaltered, when you differentiate the numerator, you get 4. By now you all will be thorough of how to differentiate algebraic functions, right? If not, please go back to the videos and learn and get back. Minus 4x to be kept unaltered, and 1 minus 2x square will be giving you minus 2x on differentiation. Divided by, you square the denominator. So this is going to be your derivative. Now let's simplify that. 4 minus 4x square plus 8x square divided by 1 minus x square the whole square. So this is equal to 4 plus 4x square, because minus 4x square plus 8x square will give you plus 4x square. So you'll have 4 plus 4x square divided by 1 minus x square the whole square. Now let's simplify it even further. Taking 4 common outside, you get this. Now we are asked to find dy by dx, wherein we have found dy by dv and dv by dx. So how do I find dy by dx? I multiply dy by dv into dv by dx. Right? So this is what is our chain rule. So what is my dy by dv? It is minus 5 divided by 2 plus v the whole square into 4 into 1 plus x square by 1 minus x square the whole square. Now if we observe, our dy by dx should be in terms of x only, right? X is our independent variable. We need to get a function in terms of x. But here we have a v also. So do we know the value of v in terms of x? Yes, we do know, right? So let's replace that and complete our solution. Now minus 5 into 4 is minus 20. 1 plus x square divided by 2 plus v. 2 plus v is nothing but 4x by 1 minus x square, the whole square. Now this one onto the new denominator. Right? Let's see how to simplify this. As I've always told you, differentiation is important and expressing the answer in the right way is also important for you to get marks. So we have minus 20 into 1 plus x square divided by, there is a fraction here, we'll take LCM as 1 minus x square. So 2 into 1 minus x square plus 4x by 1 minus x square the whole square into 1 minus x square the whole square. Now if you observe, this and this will get cancelled out because there is a square for here also and there's a square here also. So this is equal to minus 20 into 1 plus x square divided by, inside the brackets we have only the numerator. Let's open it up. 2 into 1 is 2, minus 2 into x square is minus 2x square plus 4x the whole square. If you observe keenly, there is 2 common in every term inside. So let's factorize it. Till we have opportunities to simplify, we need to keep doing it. So 2 is taken out. You have 1 minus x square plus 2x the whole square. Now this whole square is for the entire thing, right? So now what we will do is, we'll make this minus 20 into 1 plus x square divided by, this 2 is getting square, it becomes 4 into 1 minus x square plus 2x the whole square. Okay, so now this 4 and this gets cancelled. I have minus 5 into 1 plus x square divided by 1 minus x square plus 2x the whole square. Now if you observe, the denominator is a quadratic equation. So we need to write it by arranging the second degree term first, right? So let's rearrange it. When we rearrange, let's put x squared term first. But x squared being a negative term, we'll change the sign of every term inside. Meaning I'm going to take minus outside. Since there is a square there, the minus gets squared and gets nullified. So I'm just going to change the sign and leave it like this. Could we move on to the next? With that, we are done with algebraic differentiation, derivatives of algebraic functions. We'll quickly sum up of whatever we've learned so far. A quick recap of all the concepts that we've learned so far. The derivative of a function f of x with respect to x is defined as this. F dash of x is equal to limit del x tends to 0, f of x plus del x minus f of x by del x, wherein del x is greater than 0. This is called as our first principle. Now, the derivative of a constant, this is the first one that we've been using on and off. I'm sure you will all know this. If in case you have doubts in it, visit our previous videos. The next thing is, the derivative of a constant is always 0. I've always told you, if y is equal to c, a constant, then when you differentiate this with respect to x, it is going to give you a 0. Because there's not going to be any variation in a constant when another variable changes. So apparently, the rate of change of a constant with respect to a variable is going to give you a 0. Newton's power formula. This is very, very important because we've been using this everywhere when we have differentiated. So d by dx of x power n. When you differentiate x power n with respect to x, you get n x power n minus 1. The power becomes the coefficient, and 1 less than that power is going to be the power of the derivative. Now, what is the geometrical representation of a derivative? The geometrical meaning of a derivative rather. So, dy by dx of any function at one particular point is nothing but the slope or gradient of the tangent on that curve that is represented by this function. Meaning, when you have a function y is equal to f of x, when you plot it on a graph, you get a curve or straight line or whatever. Now, if you want to find the slope at this particular point of that tangent that passes through it, this slope, the gradient of this, the slope or the gradient of the tangent at a particular point on the curve is called as your first order derivative. That is dy by dx. We've actually seen in detail the geometrical meaning of the derivative. Go back to those videos to visit it once again for better understanding. The derivative of y with respect to x is the instantaneous rate of change of y with respect to x. So what is dy by dx? When y is equal to some function in terms of f of x, when x changes, it affects y. So the rate of change of y with respect to x at one particular point, that is instant, at one instant, is called as the derivative of y with respect to x. If f of x is a derivable function, there is a function f of x which you can differentiate, and c is any constant, then the derivative of c f of x, meaning d by dx of the constant into the function, is going to be c f dash of x. To give you an example, if your y is 3x square, of course x square is a derivable function and 3 is a coefficient. So 3 is a constant coefficient of x square. Then when you differentiate y, that is nothing but 3 into the derivative of x square. That is what is denoted by this. When we deal with some more differences of functions, meaning when you have two functions added or subtracted, then the derivative of the function is nothing but the sum of its derivatives or the difference of the derivatives depending on the function that we have. This we've been applying in all the polynomials that we have differentiated so far. Now comes the product rule. If any function is a product of two functions, When you differentiate this with respect to x, we use the product rule, wherein we keep the first function unaltered, differentiate the second function, plus then we differentiate the first function keeping the second function unaltered. Since addition is commutative, you can differentiate any of these functions keeping the other one unaltered and sum up both in any order that you want. So here we have kept the first one unaltered, differentiating the second one, plus the second one is kept unaltered, differentiating the first one. Now comes the quotient rule. If any function is represented as a rational function, two polynomials, or a quotient of two functions with the denominator not leading you to 0, because in that case the function becomes undefined, right? So how do you differentiate this particular function? When you have to find the derivative of phi of x, you first keep the function on the denominator unaltered, multiply it to the derivative of the numerator, minus keep the numerator unaltered, multiplying it to the derivative of the denominator, and on the denominator of the derivative you have the square of the denominator in the function. Here if you see, this order is very, very important, from which to subtract which function, because subtraction is not commutative. So first you always need to keep the denominator unaltered, differentiating the numerator. So please note all this down and practice with all the formulas in place so that it's easy for all of you to practice. So denominator into the derivative of the numerator minus numerator into the derivative of the denominator by denominator the whole square. Next comes the chain rule. When it's a composite function, composition of functions. So f of g of x, you always differentiate the outermost function first. So f dash of g of x into, then the inner function is differentiated. For example, d by dx of x plus 1 the whole square. So here it is the power function that has to be differentiated first, the outermost function. So what do? You apply the power rule, keeping the base unaltered. You're not doing anything to the base, just using the power rule. Into, then you are differentiating the function, that is the inner function, that is x plus 1. And you get 1 there. So the answer is 2x plus 1. So this is called as the chain rule. When we deal with different types of functions, you will understand better. So derivative of f of x with respect to g of x into derivative of g of x with respect to x. So with respect to g of x, you first differentiate the outer function and then differentiate the inner function. You will know better when we do more examples of this sort. Now, the last and not the least is the second order derivative of y with respect to x. So, already differentiated function, when it is again differentiated with respect to the same variable, you call it as a second order derivative and you express it as d square y by dx square. That's all for this video. Thank you. Sai Ram.